This video presentation is brought to you by the Pro Mathematics Academy. Welcome to this video presentation brought to you by the Pro Mathematics Academy. In this video, we'll be continuing our series on limits, right? Which is part 2 of our tutorial exercise set number 1, along with some bonus questions at the end. All right, so without further ado, I jump right in, right? On our first question, asks us to find the limit as x approaches 0 of x raised to the 5/2 minus x raised to the 1/2, all divided by x raised to the 3/2 minus x raised to the 1/2. So as usual, we need to simplify our expression. And here our expression is x raised to the 5/2 minus x raised to the 1/2 divided by x raised to the 3/2 minus x raised to the 1/2. So here, let's make an important note, right? So if we eyeball this question, right, we would recognize that we have x raised to the 1/2 in both our denominator and our numerator. So here we would say that we need to factor out x raised to the 1/2 from both numerator and denominator. Okay? So this implies that x raised to the 5.5 minus x raised to the 1/2 divided by x raised to the 3.5 minus x raised to the 1/2 is then equal to x raised to the 1/2 times x raised to the 5/2 minus 1 minus x raised to the 1/2 minus 1 over 2, right? All divided by x to the 1/2 times x raised to the 3/2 minus 1 over 2. Here, this should have been 1 over 2, right? Minus x raised to the 1/2 minus 1/2. So here, we can cancel, right, x raised to the 1/2 from both the numerator and denominator, right? And now our expression simplifies to x raised to the 4 over 2 minus x raised to the 0 divided by x raised to the 2 over 2 minus x raised to the 0, right? And we know that x raised to the 0 is equal to 1, right? So note, x raised to the 0 is equal to 1 if x is not equal to 0, okay? So this is something that most of us, we already know intuitively, but I just wanted us to know that again. All right, so here this becomes x raised to the 2nd power minus 1 over x minus 1. So this means that we can further simplify this, or we can find the limit at this point. So I'm going to go ahead and find the limit. So this means that the limit as x approaches 0 of x raised to the 5.5 minus x raised to the 1/2 divided by x raised to the 3/2 minus x raised to the 1/2 is equal to the limit as x approaches 0 of x squared minus 1 over x minus 1. A lot of persons are wondering, why didn't I try and factorize this expression further? The reason is that we don't need to factorize it, okay? So we can go ahead and evaluate x squared minus 1 over x minus 1 at x equals 0, which is equal to 0 squared minus 1 over 0 minus 1, which is equal to -1 divided by -1, which is equal to 1, okay? So we have our final answer, right? Moving right along to question number 10. Okay. And if we look at question number 10, we realize that it's asking us to find the limit as x approaches 8, right, of x minus 8 divided by x raised to the 1/3 minus 2, right? And as usual, we start by simplifying our expression. So now x raised to the x minus 8 over x raised to the 1/3 power minus 2 is the same as, here we need to do long division. Okay, so here we take x raised to the 1/3 power minus 2 and we're dividing that into x minus 8. Okay, so the first step is to divide x by x raised to the 1/3 power. This is equal to x raised to the 2/3 power. Okay, so that same x raised to the 2/3 power goes right here. And then we multiply x raised to the 1/3 minus 2 by x raised to the 2/3, which is equal to x minus 2 times x raised to the 2/3 power. Okay, and now we take this x minus 2 times x raised to the 2/3 and we put it right here. Minus we now subtract, right? And this gives us 0 plus 2 times x raised to the 2/3 power. The next step is to take 2 times x raised to the 2/3 power and divide by x raised to the 1/3 power. This is equal to 2 times x raised to the 1/3 power. Okay, we now take this 2 times x to the 1/3 power, right? And we add it here, 2 times x raised to the 1/3 power, right? So now we need to take this 2 times x raised to the 1/3 power and multiply it by x times, well, multiply it by x raised to the 1/3 power minus 2, which is equal to 2 times x raised to the 2/3 power minus 4x raised to the 1/3 power. So this expression, we now take it and we add it right here, 2 times x raised to the 2/3 power minus 4x raised to the 1/3 power. But we do not forget our negative 8, so we still have negative 8 right there. But when I subtract this, I now end up with 0 right there and a positive 4x raised to the 1/3 power. Final step, right, is to take 4 times x raised to the 1/3 power and I divide by x raised to the 1/3 power. This is equal to 4. So now I take this same 4, right, and now I add it right at the top, and we take our 4 and multiply it by x raised to the 1/3 minus 2, which then gives us 4 times x to the 1/3 minus 8. So now we take that 4 times x raised to the 1/3 minus 8 and we add it right there, but do not forget we had this minus 8 coming all the way down, so we still have a minus 8. And if we look at both of these expressions, we realize that we end up with 0, 0. So that's how we long divide two functions. Okay, I was just about to say that's how we divide two polynomial expressions, but I realized that these expressions are not both polynomials. Only one of them is a polynomial. So now we can see that x raised to the 1/3 power minus 2 times x raised to the 2/3 power plus 2 times x raised to the 1/3 power plus 4 is actually equal to x minus 8. Okay, so what we did here was to factorize x minus 8, right, based on the question. And now once we have those factors, we can go ahead and evaluate the limit. So now we have the limit as x approaches 8 of x minus 8 over x raised to the 1/3 power minus 2 is equal to the limit as x approaches 8 of x to the 2/3 power plus 2 times x raised to the 1/3 power plus 4, right, which is the same as evaluating x raised to the 2/3 power plus 2 times x raised to the 1/3 plus 4 at x equals 8. So now we simply substitute 8 everywhere we have x, and this then gives us 2 times, which is equal to 4 plus 4 plus 4. And that is it for this video. Please remember to hit the notification bell, like, share, and subscribe for future post notification.